Yes. Good morning and welcome. I'm Mads Thompson. Usually I'm a professor of comparative literature, but I'm also the director of this program, Digital Literacy, which is sponsoring the statistics course. Some of you are on the course, some of you have joined here, but most of all we're very happy that Josh has been able to take time out of his schedule to give us a crash course in statistics using R. So I look personally, because I'm on the school bench myself, forward to 14jan19 days. There's already coffee, there's water, there will be sandwiches, there will be cake, so we can focus on learning today. I've started a camera recorder because there are a few people who couldn't be here today but will join us. They asked, could we have some video of the first day? So just mind that we have a recorder standing up here if you want to yell at Josh or something else. Other than that, I'll hand over to Josh, and I will feel very confident about that this will be 3 days, great days with significant output. So
great, thank you very much, Matt. And in addition to me, I also have assistants from Adela Sobotkova here, who is going to be running around helping with tutorials and helping with exercises, and basically helping with explanatory things that I miss. Because it's been a while since I've learned this, and this is one of those topics that it's really easy to remember, easy to forget how hard it was to learn in the first place. So in that context, please feel free, if there's anything that I'm saying that isn't clear, if there's anything I'm saying where you feel lost, please stop me and ask questions. And this is, I mean, all teachers, you're all teachers yourselves, you know that we all say that there's no question that's too stupid. In this situation, it's more important because it's a very sort of progressive type of material. That means things build on top of each other. So feel free to slow us down. I haven't jam-packed the 3 days with so much material that there's no time to pause. I've tried to make this a sort of an airy course with space for questions, space for more understanding, space to go through things multiple times from different perspectives. So we're not in a rush. That's the goal of this entire 3 days. Basically, time to take some time out, learn statistics, work through the stuff in the book, work through the nuts and bolts, work through the practice, and it's all intended at an extremely beginner level. So there's absolutely no background to this course other than a tiny little bit of high school algebra. But I'll also explain that in a hopefully pedagogical way. Before we start, it can be helpful to get to know one another, to get a sense of sort of who's in the room, what sort of interests are in the room, what sort of research you'll be using statistics for. So I'll start with me. Don't worry, all of my slides don't have this much text in them. So I'm an associate professor in cognitive science at the moment. I'm also the head of department for the department LICS, which is linguistics and cognitive science, and semiotics. I'm the co-director for the Interacting Mind Centre, which is just down the stairs here. One of them's at IKK, one of them's at IKS. I'm sort of spread out all throughout the institute these days. I'm a humanist. I come from the humanities, but I have a very blended background. My first degree was in ST, in psychology, where I did what we called those days stats and rats, where we did experiments on snails, learning experiments, and we dissected sheep's brains. And we did a lot of statistics, so that's why I learned about statistics. I wasn't the best person at statistics. I was sort of in the middle in my degree, and then I came to Denmark and did philosophy, and suddenly I was the best person in statistics. So I did a master's in philosophy here after having moved to Denmark, and then sort of started hanging out with people from the hospital, from the health department, and from the humanities department that were using brain scanners. And it was basically a lot of humanities people from anthropology and linguistics trying to figure out how to do behavioural experiments, and suddenly I was the expert, which sort of threw me into these teaching situations. So sort of by accident became a teacher of statistics or research methods. That sort of reinforced itself, and at the moment my research interests are very much in cognitive modelling, so very much in using more advanced stuff than we have here to develop explanatory models of the generators of behaviour inside people's minds. So philosophy and psychology and statistics coming together. And this is the sort of thing I teach at the moment, mostly. Mostly I have been teaching this sort of material, this basic sort of introductory material at the humanities faculty since about 2007 at bachelor level, at master's level, at PhD level. This is my first sort of staff development context, so that makes this interesting. And I teach some more advanced stuff on the cognitive science degree. So what I want to do now is to get a sense of why you're here. And this is useful for me because then I'll sort of we'll know one another, but it's also useful for me to know what sort of pitching I can use. So I can refer to your field, I can refer to your research project, I can think sort of more from your perspective about the kinds of problems that you're going to encounter. So we'll quickly go around the room, and can I just get your name, your department, and why you're taking this course? And that could be because you've got a specific data set that you want to work with. That could be because you've got a PhD student who you want to understand why they're doing what they're doing. That could be because you want to end up like me and accidentally become the statistics teacher for your department. Whatever that is.
Hi, my name is Ray. I'm a PhD student in media studies. I'm looking at how government censorship is shaping the reception of television dramas in China. I have to be honest, I'm not too sure how I want to use this yet, but I'm just curious.
Yeah.
Mads Rosendahl-Thomsen, still comparative literature. What drove me into the field was an interest in world literature and the literary sociology of how works they get disseminated across the world. And we have so many more data sources to try to understand that than we did just, say, 15 years ago, but they need to be calculated.
My name is Anne, and I'm a PhD student at the study of religion, where I'm working on a large sermon corpus, with contemporary Danish sermons, where I'm looking into how characters, different types of characters are represented and what different cultural domains they represent in the sermons. And I have been introduced some to working in Python with text, but I would like to use this course also to understand some of the statistical foundations of using programming language.
My name is Adela. I'm an associate professor at the Department of History and Classics. I'm an archaeologist and work with landscape, large-scale, regional data sets, so statistics is always useful, although I mostly use spatial statistics. I'm here mostly because this workshop entails R, and I'm a software carpentry instructor. And so I'm interested in what sorts of problems you might have with R, and it's just for me, it's another opportunity to help people and see what obstacles people usually face. So one thing that I also will add, you will have received these two sticky notes from me. They are for signaling your difficulty. Because Josh invites questions, and people have different facility with asking questions in this sort of forum if they don't know each other. So whenever you get stuck and you can't, you may just be working on something, that's fine. If you get stuck, just put up a sticky note like that. It signals to Josh maybe he needs to slow down, increase his font, or scroll and go over the last concept. Or I will, if it's just one, I will come to you and I will try to help as best I can. Again, if you're fine, and this is especially for the afternoon class, but we may even try it in the theoretical one. If you're fine, you just keep the green sticky note up, and that just means, yes, I'm following along. But if you get stuck, signal this before you get entirely lost, because what I usually try when teaching R is, technology is frustrating enough as it is. Let's try to make it easier. So, early signaling means you don't get lost, you don't miss on all of the stuff. And also there are probably other people in the class who are having the same problem, just not signaling. So that's for your ease.
Is that a software carpentry thing?
That is a software carpentry signaling trick.
Nice.
Yeah. You can even use yellow ones for I'm in progress working on it. But I didn't find any sticky notes in my office right now. So these are the essential ones. Anyway, don't hesitate to ask for help.
Alright, thank you. I'm Rasmus, and I'm also from media studies. I teach, among other courses, quantitative media analysis. That's mainly why I'm here, to be able to supervise students in need of help in case they can't get in touch with Hans Peter, who actually takes care of the statistical part of the course. So yeah, I'm mainly here to freshen up my knowledge of statistics.
Well, I'm Peter. For media studies, I'm definitely here to get a grip on R. I don't really know about the software, and I'd like to get into it.
Yeah, I'm Jana. I'm from media studies. I'm working on projects with web history within this program. And full library down there, yeah. And we're using the Cultural Heritage Cluster at the Royal Library with Cultural Heritage Materials. So, and that runs with art. So, and then we've been trying to do some visualizations and realized we need more statistics for doing proper analysis and visualizations. Yeah.
I'm Leah Skews, married to Joshua Skews.
He by force.
He's sick of answering questions at home, and I have to come. I'm a gender studies, and I just started a new medical project. So I think the hope of the people that hired me is that I will learn R and do all their stats, and I have to start from scratch. So that's why I'm here. I'm not homeschooled.
My name is Charlotte Blaine. I'm at DPU, so just the other, just across the wall. I'm mainly here for the same reason as I'm trying to learn R. I have some statistical knowledge, but it's a few years back. So I'm mainly here for the course, and perhaps I'm going to use R in a project that I'm working on right now about mentoring.
Yes, Ulf Bertelsen. I'm an associate professor at the Danish School of Education. And I'm part of the digital literacy project, and I'm trying to build a corpus of student texts so I can use NLP tools to look into how language develops over time, mainly in school context. And I need some statistical tools to kind of describe the development.
My name is Christian. I'm a PhD student at DPU and KUDEM. And I have survey data and transcriptions of interviews, basically, about students' use of digital media.
My name is Nils Brugger, and I'm a professor in Internet Studies and Digital Humanities at the Media Studies Department. Colleague to Jana, to a couple of others. And together with Jan and Ulrik, we work on studying the historical development of the Danish web in its entirety, which is quite a big business. We have managed to get it in format so it's actually crunched like figures now, but we would really like to know much more about what we actually do. So that means
my name is Louise. I'm an archaeologist doing a PhD on early Bronze Age burials, and I've collected my data now, and I'm going to do network studies, but I also would like to look into some possibilities with these statistics. So that's it.
I'm also a PhD student of archaeology, and I'm ready. I'm looking into diet chains from the Mesolithic to the Neolithic, so we're saying the period before farming was introduced to the period of farming was introduced. I'm using isotopes studies, so I'm a little bit in the science stuff, so I'm using it as well, and I'm also here to learn to use R.
I'm Valentina, and I also come from the Department of Archaeology. I study also Bronze Age networks and metal trade, and yeah, I started having a lot of data, and I think a statistical research for me.
Yeah.
Know how to use R.
Okay, hello everybody, my name is Christian Sportloso. I'm a postdoc in the classics department. I'm an ancient historian. The reason why I'm here is just to learn more about how I quantify things, and I'm looking specifically at Latin paleography, so Latin manuscripts. And I got an awful lot of those, so I'd like to know how I organize them in the best sort of way, and I hope this course will teach me more about statistics and how to use statistics and that sort of research.
I'm Lars, working at the local library here at Parken. I think my interest is that each year I do the library statistics, and I forgot most of the statistics I had back at social science ones. And also that now we have become part of the Royal Library, I know they use R for much of their work, so it might be good to understand some of that, and also just to be able to visualize data now.
I'm Rebecca, and I'm working still with the political scientists and physicists at the moment and mathematicians. And I would also like to learn more about t-tests and all sorts of things. And I'm applying my analysis to, I have been applying to Facebook data, different location individual data, and now I got some millions for a project on disinformation cascades. Now we're going to apply it to measure effects on information flows on different variables. And we are also going to do a agent-based model with the data that we already have in our lab and data from the sector to see whether we can tweak on certain parameters to slow down the spread.
Hi, I'm Anne. I'm a PhD student at media science, and I would like to get to know R better, and also I would like to know more about the work that engineers are doing when they're constructing machine learning algorithms, because that's a part of my project. So that's basically what I need.
And I'm Lønge, research assistant at Media Studies, and I'm going to be working on Anja's projects, and as she explained, statistics might end up being very useful.
Yep. My name is Kirsten, and like a lot of the other people here, I'm from Media Studies, which is actually called Media Studies and Journalism. And journalism is my field. And the reason why I'm here is this is the first opportunity I've ever come across of, actually engaging with statistics at the beginner's level at this point in my career. And I'm not sure what I can use it for, because I don't know it. But I do know that at the moment I'm reading articles about people's ability to recognize native advertisements, which is, it's a lot of things, but in this particular context, it's those articles, or rather it's advertisements that look like articles. You might not realize that this is the whole idea. And there's a lot of statistical research within advertising studies about this. So I read the bits about how we could, what we know about it, this is our hypothesis, and I'm all there. And then suddenly I arrive at strange figures and things, and they say funny things about it, and I have to jump to the bits at the end where they sort of sum up. So this is what we learned in sort of normal human language. And it's the in-middle bit. Like
critical statistics.
Yeah.
Yeah.
There are people doing peer review here. I'm sure they got it right, but I don't know what's going on. And I'd like to know a little bit more about what's going on in there.
Okay, I'm Helle Snyder-Jensen. I'm from History and Classical Studies, and I'm the co-director of the CEDAR Center for Digital History together with Adila. I'm interested in how historians use digital archives, and that also increasingly involves, actually like Kirsten said, assessing how other people use quantitative data, and so this will be very helpful for me to also, maybe in the future I can use it for my own data, but now it's just for getting to know this R better and getting to know statistics better. Well, historians have used statistics for many decades now, but I'm not particularly good at it.
Yet.
My name is Anne Sørensen. I work at the Department of History and Classical Studies as well. I work at the website Danmark Historien DK, which is focused on dissemination of knowledge. I want to get better at statistics in general, try to refresh something. If there's something to refresh, I'm not sure. I want to know something about R, and I'm especially interested in visualizations of historical facts and historical developments. How can we make a picture of this in order to explain things that way to the general public?
Yes.
I'm Ulrich. I work in NetLab, which has already been introduced by Niels and Jenna. We as I said, we work with a lot of data. So for more than a year, more than a year, I've been working on this data, and then it's been interesting. So there's been a lot of statistical issues, I think, that we are looking at and visualization as well. So I do a lot of support tasks for various researchers. So I can see a need for actually every humanities scholar and research to have this course. I think it's very helpful. Yeah.
Good morning, my name is Anastasia. I'm a PhD student at the Department of Ecology and Heritage Studies. My project is about leprosy in medieval Denmark. So I'm working with human skeletal remains and also stabilized analysis. And I'm interested in the diet and the origin, among other things, of people who lived in leprosy hospitals during the medieval period here in Denmark. And I'm pretty sure I will need knowledge of statistics, and probably I will use R when I will get my results. So this is what I'm doing.
Okay, great. Thank you very much. This roughly reflects my experiences and expectations in terms of departmental distributions, in terms of interests. This is what I see at all levels of the kinds of interest that we get from people from humanities. Roughly this many historians, roughly this many archaeologists, roughly this many people from media studies, whether it's at bachelor level, whether it's at, so this is a nice group to work with. One of the things that I'll say, and also the right kind of distribution of intention that I'm used to as well. So some people are here to refresh, some people are here to use statistics on a concrete project that they've got now or that they're getting in, and some people are interested in this sort of critical ability to read papers. And they're all three extremely good reasons to learn this content. For the last group, I will say, commit now to finding a data set from a colleague, from a friend, from online. Ask me after the course and come up with some hypotheses relevant to that data set and analyze it. Use R straight away. Because if you don't actually use it and if you don't start digging around with it, it's a practical skill. It's kind of like if you went to, if you're say a beginner guitarist and you go to an intermediate workshop and then you don't play guitar for the next 6 months, you'll forget everything. So it's very important to get it a little bit under your fingers. That's the main piece of advice that I'll start with. Okay, so in terms of the course outline, what are we going to get through today? And how is this going to fit into your needs and intentions? So today's start is more broad, it's more philosophical, it's more background. I'm not going to be talking about t-tests, I'm not going to be talking about p-values. It's about approaching research quantitatively and the kind of assumptions that you have to make and the kind of philosophical background that you take into doing research. And this is sort of the content of the start lecture. And then this afternoon, we'll start walking through R and RStudio. So hopefully everybody's got R and RStudio installed, but if not, this is also a good opportunity to get everything running before we sort of dive into the stats stuff tomorrow. So we'll have our approaching data, sort of approaching R session in the afternoon. And then tomorrow, we start on sort of the basic concepts. And here we cover basic ideas, not specific tests, not specific how do you run a regression, how do you do a t-test, how do you do a chi-squared, but what concepts are relevant for understanding all of these different kinds of statistical tests. And the idea here is what concepts are relevant for implementing the kind of philosophy or the philosophical assumptions that we make and that we learn that we've made in the first day. So how do we start approaching numbers with a research question that we frame? And that's what exercise 2 is about. And I can see we might have some lighting problems. Is anybody blind and needs to put a blind down? We should just do that. It's that one. And I think that last one up the back too. Could you please because there's people that can't see. And that one too. Can you also, is it? It's this one.
It's your perspective, sir.
That one too, maybe. That's you? Okay, good. It's very distracting for me as well if people are sort of like, okay, good. So he will cover some concepts, and the basic concepts here are samples and populations, and models and hypothesis testing, and that's what we're going to be interested in tomorrow. And then in the exercises, we'll start using R for statistical machinery. And then in lecture 3, we'll start talking about the general linear model. And we'll stop here. And the reason that we stop here is this is actually a really nice place to get to, because this is the general framework that you need basically for all null hypothesis significance testing statistics. This is sort of the starting point. You can go off in all sorts of different directions from here. You can go off into machine learning from here. You can start to go off into parameter estimation from here. You can do lots of different kinds of statistical bells and whistles added onto this basic starting point. So our goal is to get to this point of this general linear model. And here we'll cover these concepts of correlation, regression, and this basic idea of what is a general linear model. And it's here that we'll get as mathematical as we get, where I'll introduce some ideas from algebra, linear algebra. But everything else I'll frame in terms of sort of logic, without doing math. There'll be equations, but I'll explain the logic of the equations. And by the end of the course, I'll have you running your own linear models for different sorts of data. For a very restricted sort of data. But it will be a starting point, it'll be a framework for you to jump off and do other things down the track. So basically, what I want you to learn here is not to be a statistician, is not to be sort of a hacker extraordinaire, but to have some confidence in what you're doing and some competence in what you're doing. And this is, data science is a sort of a new field that's come out, and there's lots of online data science courses, and they all use this in their advertising for how you can follow their online course to become a data scientist. And there's some sort of nice bits and pieces, sort of nice cut-off points in the progress of learning this material. You start off with the hand-holding honeymoon, and that will be what this course is about. And then the cliff of confusion is when you start to sort of think, well, actually I understand this really well, it's going really well, and now I don't get any of it again and have to start again. And then you end up in the desert of despair when you're ready to throw it all in the garbage can. Unfortunately, I won't be around for that, but please do write to me. And then you keep working, and you get to the upswing of awesome, and then you start to get all of your tools ready. Realistically, I'd love to be able to get you to here. So this is what I think we can do. If we can run a general linear model, you can start to be able to go and use the field textbook, use online resources to find out how to then run a logistic regression. And if you know how to do a logistic regression, you can start to understand the fundamentals of machine learning, and so on, if you need to go in that direction. And then you'll be job ready. Hopefully you're already job ready. The problem is that this is really not a realistic picture of what it's like to learn this material. It's kind of more like this. So this is sort of the different languages for learning, representation of learning curves for different languages, and here's R, basically. And R, in many ways, is a nightmare language to learn. And the reason for that is that it's a language, but it's not really a language. It's a language more in the linguistic sense than the computer programming sense, in the sense that it's got users that customize it and change it, and it has cultural effects in the way that it evolves and the way that it develops. So we won't be working with any of that. We'll be working with what's called base R. Everything that I'm going to be teaching here is in base R. And there's kind of another add-on aspect of R, and this is the people that made RStudio. This is a world called Tidyverse. This is kind of like Retskrivingsordbog, if you're Danish. So this is like the rules of R, and there's a sort of a group that works on that. And then there's this wilderness of people that contribute to the language and build functions and build packages, where a lot of it's on the cutting edge of statistical research. So you don't need to know all that. You can't know all that. That's not the point. The point is to see R as a tool, see R as a basic syntax that you can start to do simple things with, that you can yourself easily interpret and build on progressively and incrementally as you start to use it in your own research. So don't get lost in the wilderness of R. And the aim here is to not bring in any functions that aren't native to base R, not to bring in any packages or any bits and pieces that have sort of been built by developers who are working on the frontiers. We're not even going to do tidy text stuff. I'll mention it towards the end of the course. We're just going to stick to very simple plots, very simple functions, and so that you know the language and you know the syntax. And then you can turn to the Weizsäcker-Software. Okay, so today, lecture 1 is approaching quantitative research. And today I'll start you with a short-ish lecture on philosophical assumptions. And this is something that a lot of people from the humanities, this sort of material is something that a lot of people from the humanities are familiar with. Covers a lot of the sort of philosophical background that you bring in to doing research methods. But I think it's useful at all levels just to reiterate this at the beginning. I think it's always useful to step back and say, well, are we doing what we think we're doing when we're running a study with numbers? Are we actually capturing the concepts and the information that we think we're capturing? So I'll start here and aim to finish this off at around lunchtime, which is at 11:30. If we finish a little bit early, I'll start on the demonstrations. I don't think we'll be late, but please interrupt. Please feel free to stop me. But otherwise, sit back, relax. This is the humanistic part. This is the world that you're safe in, I think, for the most part. That's the goal, at least, when I teach this. So the course is bounded. There's, at the moment, 3 dominant models of statistics, 3 dominant philosophical assumptions or philosophical frameworks that we use when we do statistics. And that's the likelihood or the estimation framework, the frequentist or the hypothesis testing framework, and the Bayesian or the inference belief framework. And these have all different assumptions, different interpretations of the numbers, different interpretations of the values, different strengths and weaknesses. At the moment, I'm probably most aligned with this one. This is where my real passion lies. For a lot of where I think the field is going and where the fields that you're working in are going is mostly this one, this likelihood estimation. But our focus will be on frequentist or hypothesis testing framework. And the reason for that is exactly because of what you were saying before, some of you were saying about having a critical understanding of all of the numbers that suddenly come in the result sections of a paper. This is the dominant framework that people in the fields that you're working in, if you're not working with engineers and people doing machine learning, this is the dominant framework that most quantitative research that's within the humanities works within. So you're doing different things when you're doing these different kinds of statistics. And learning this one can be useful also because it can give you some insights into this one, which is the one that you're going to encounter. So here, you're generating hypotheses and testing them to find out whether you were right. And here, you're trying to find out what a specific value is. You're trying to say, well, what is the affective score of, what is the score that I should assign to the affective content in a bunch of Facebook posts? And that's what this one's for. And these are more related. So this is what you'll encounter most in the wild. So this is what we'll start with. So there's a basic philosophy behind this frequentist approach, this what we call frequentist statistics, or hypothesis testing. And that basic philosophy is logical empiricism. So this is the dominant philosophy of science that was around in the 1930s, when all of the statistical work was done as well. So it's the classical scientist model. Not scientist as in person, but science-tist model of interrogating the world. It's outdated. It's limited in scope, and it doesn't apply to many of the problems that you'll be working with, and it's potentially very misleading. So it should not be as widespread as it is, but it's very dominant in applications. And there's a historical reason for that, and that historical reason was these are the philosophical debates about what science means that were going on in the 20s and 30s, that the statisticians picked up, that the psychologists picked up, that the sociologists working at that time picked up, and the fields got crystallized there. And it's all starting to loosen up now. But in learning this framework, like I say, you'll also learn something about estimation. So what am I talking about when I'm talking about this classical scientist model of hypothesis testing of statistics, of interrogating the world? Well, it's basically dividing the sort of inquiry, the logical inquiry that we do, the kind of interrogation that we do up into 4 steps. Those steps are observation, explanation, prediction, and control. And if you keep those 4 steps in mind through the process of learning the rest of the material, you won't go too far wrong. Essentially, what we're trying to do is find a way to verify, using numbers, that we've done the right thing at these 4 different stages as we go along. So, I mean, and this is fairly intuitive when we observe. We do things like we go out and we see a phenomenon in the world. And so the classic example from physics here is Ørsted, who saw that electric fields induce magnetic changes. So this was an observation. This was not a theoretically driven thing that he did. He just went out and observed the phenomenon, labelled it, and gave it a name. Ampere then came and explained this phenomenon, so basically constructed a theoretical account, and this theoretical account was the theory of electrodynamics. So that explains, that gives you some explanatory framework for understanding these observations and linking them up to other observations. From there we get prediction. So if the theory is right, we can then go out and find new phenomena, surprising phenomena, interesting phenomena that we might not have found in other contexts without the theory there. And the example here is that, well, if you move a charge, then you'll induce something that's charged, you'll induce a magnetic field. So this works for sort of classical mechanics and classical electrical theory. And control, we can harness this knowledge to improve humanity. So Charles Babbage, took this knowledge to invent the electric motor. And then we got electric motors on the basis of this observation. So we observed, we explained, we predicted, we controlled. And statistics comes into play for all of these things, basically. And you might think that seems to work in physics, but we all know that it doesn't work in the social sciences, but that's not for want of trying. Coming from psychology, coming from a psychology faculty at a science and technology faculty, we tried really hard to stick to this kind of model. So if you think about psychology, then we had an observation back in the early 20th century that cats take less and less time to escape from a puzzle box if you stuff them in a puzzle box. That was Edward Thorndike's research. Started basically learning theory. The explanation for this was the law of effect. There's some conduit between responses and outcomes that got strengthened over time. From there we got Skinner came along and constructed a prediction to make new explanations, new predictions of phenomena that we wouldn't have had if we hadn't have had this sort of explanation in advance. And that was, well, if we reinforce a behaviour, we can increase its frequency, we can reward it. And then we can control the world by having new technology of behaviour based around reinforcements that gets people to do what we want, so that we don't need to be punitive. So we have a technology of behaviour to create a better world. And Skinner wrote books and books and books about this. You don't need free will, you don't need prisons, you just need a technology of behaviour that will shape the kind of citizen that you want. And he wrote a novel about how great an idea this was, and that inspired Huxley to write a novel about how horrible an idea this was, because it drains us of our humanity. So it's not for not wanting to try, but this is the sort of problems that you can get into if you take this model too seriously. So maybe we don't do that anymore in society. Maybe we've sort of learned from the 20th century that it's not such an idea to try to create this totalitarian world, but we kind of do use this model. So an observation might be that we see crime increase. An explanation might be because there's increased drug addiction. Our prediction might be that, well, if we have a methadone clinic in an area, we'll see a decrease in crime. And control could be that we just go up and set up more methadone clinics. And then we go out in the world and set up methadone clinics and monitor this intervention. So in a very simple way, we are using the scientist model in the way we do policy. There's two sides to this coin, though. You can have other hypotheses. So another hypothesis might be that you see crime increase, and the other explanation could be, well, punishment's just too lenient. So let's make prison harsher and with longer sentences and see if that reduces crimes. That's another way to sort of control the world. And we can use numbers in these two debates and have these two separate different hypotheses. And that's essentially how policy goes on these days, with more and more complicated models. So it's not too far from the truth in practice, even though it's associated with a whole bunch of problems and it might not be the right way to do things. So we live in a world where we do tend to use this more and more. And I put all of this in because it's very important to understand the limitations of the statistician. Understand the limitations of the analyst. So, and it all comes down to this point of control. What is our role as humanistic researchers working with data in shaping this process to improve the world? And I tend to advise an alternative liberalised notion of control. Because along the way, we face a lot of risks in our analysis, in our interpretations, and we need to be mindful of those risks. So I like to foreground everything with this sort of discussion. So we can be wrong. If we're going to actually go out and control the world, that requires that we implement our theory, and small errors can be inflated over large timescales. And when you scale things up, real people's lives are involved, and small mistakes in your model can lead to big mistakes in real life. There's risk of incompleteness. So if you've got a control, if you've got some sort of intervention that you want to go out and roll out in the world, that's making a ton of assumptions about the world, and it's assuming that you know all of the relevant variables, and you might not. You might not know. You might have hidden blind spots that you're not aware of. So really there's no room for assumptions in an intervention, but you have to make assumptions. You always have to make assumptions in any statistical model. And most importantly, there's this risk of paternalism. And this is why I like to give this course at a beginner level, is because the more people that know about statistics, the less this risk of paternalism exists. So we shouldn't have all of the knowledge relevant for this process sitting in the hands of engineers and economists. People from the humanities should have this knowledge as well. Because then we can understand the kinds of control structures that are built in to analysing the world with this scientific data and with this scientific approach to change. So I say rather than control, what we should be doing is informing decisions or counselling. So our role is as counsellors. So that mitigates, I think, these four problems that you would normally have in a control-focused model of a scientist approach to changing the world. So risk of error, you can acknowledge fallibility and publicise your success rate. So publicise all of your data, publicise all the experiments you run. Make sure that everything's open. Make your data freely available. Then other people can spot your errors. Risk of incompleteness. Try to acknowledge your ignorance. Try to say when you don't, what the limitations of your knowledge are. Try to make all of your gaps explicit and try to publicise your assumptions when you publish your results and when you work with other people in other sectors. And to counter this risk of paternalism, try to see science not as something that's in the hands of scientists that are all-knowing and can control the universe, but as something that's a publicly available good. So try to democratise this knowledge as you go out and spread it with others. And wherever possible, leave decisions up to individuals. So the role of the statistician then, and this is how you know you're working with a statistician and not an engineer, is that statisticians are very much along these lines. They'll tell you what you should believe. They'll tell you what you should think, given your assumptions. They'll talk to you and say, what are your assumptions? What do you think? How should we build this model together? Okay, this is what it says. This is how your belief should change. If you keep all of those assumptions that you had before. But remember that those assumptions are there. Whereas if you sort of work with economists and engineers, they're more, this is how the true reality is. And now we are going to intervene on that reality to fix things. Be the statistician is sort of the indication that I'm giving. But there's even limitations on this liberalised model of control. So one is that numbers can't settle issues of value, of course. You can't make society 20% more just. You can't make society 20% more beautiful. You can't, there's certain concepts that are just not naturally quantified. We can try to quantify them and we'll talk about what that would mean. But remember again, here we have to make assumptions. And all of these assumptions come before you actually start working with numbers. And they come before other people start working with numbers. And it's legitimate to take these up in peer review when you're reviewing papers. There's room for interpretation in any data set. So if we have anybody with a background in philosophy, I can say that data is always theory laden, or interpretations are always theory laden. There's never just facts and effects that just appear out of a data set. There's always theory that goes into constructing a data set. And there's always theory that goes into interpreting the meaning of any data set. And that's also the case for very, very nerdy physics stuff, like bubble chamber research and stuff that's done at CERN. Here's a great comic that you can read later on. But basically what it is this guy who's an engineer became he started writing PhD comics, where he became a comic artist for a living and dropped out of academia, but he still maintains a connection to academia by basically making fun of it all the time. And what he does is he goes to CERN and he interviews some people, and he tries to get to the bottom of what they're doing. And the most important part here is this physicist that he's interviewing. She says, well, being a good physicist is knowing how to approximate. You have to decide what's important for what comes out of the sensors and what's noise and what can be discarded. And there's no objective hard and fast rule for saying that this is noise and this is signal. And there's no objective hard and fast rule for what terms are in the equations. So sometimes people, even for the equations that embody these theories about how the physical universe works, where there's a one-to-one relationship between the concept and the parameter in the equations, they have to just add stuff to make the equations work. And I mean, the gravitational constant is the cosmological constant is the classic example in physics that most people know about. So there's always interpretation going on. There's always inclusion of some sort of philosophical assumption. And some phenomena just can't be quantified. So happiness, pretty much anything psychological. Valence, this is important for the people working with NLP. So if you're working with affect and things like that, and stuff that you need to interpret. Yeah?
Yeah, since you're a psychologist, you know Denmark is the most happiest people in the world.
Yeah.
How did they quantify that? You know?
That was, I don't know. Did they use surveys for that?
Yeah.
And basically just said, how happy are you, right? In a few different ways. Yeah?
Basically, it's not happiness, it's lack of fear.
Ah, okay.
That's how they measure it. That's how they measure it. So they say, like, the less fearful you are, basically, the more happy you are. So if you're living in a very trusting society, that basically means living in a trusting society. How you measure it, well, that you can measure in other ways, but it's easier to measure than happiness, I guess, if you want to, or if you say you can. It's easier to justify.
And there's lots of different.
It's lack of fear.
And there's lots of different ways to do that. You could look at Facebook posts and see what the valence of people's affect is in their posts. You could do experience sampling where your phone buzzes and you have to rate on a scale. And these would all rank the countries very differently, I think. But thank you for that. I didn't know that. Makes sense. Pretty much everything we do involves some sort of interpretation like this. So how do we do it? Basically, we've got two groups of problems. We've got this problem of approximation. So how do we approximate? Being a good physicist is about knowing how to approximate properly. And how do you do quantitative research on things that aren't even quantities? So let's cover that sort of as the beginning. So if we start with this basic intuition, the basic intuition about how science works, and this framework that we've inherited from the days of logical empiricism, says that what we're doing as scientists is discovering causes. We're going out there and trying to discover causes and what causes the different effects that we're interested in. And we should manipulate those causes and measure the effects of those causes. And then we'll have a causal model of what's out there. We'll have the mechanisms of the thing that we're interested in. So empiricism tells us that this intuition's wrong, basically. That we can't know causes. All we can know is constant conjunctions between things. We can't get causal mechanistic models of the world. We can only see the data that we can see. You can't see a cause. So all you can do is see things happening one after the other regularly with a certain temporal order, and then you imagine that there's a causal link between them. So this is sort of the intellectual climate around the time that all the statistical methodology that you'll be learning, this was the sort of dominant intellectual climate. And from there, from sort of Humean empiricism, which became very dominant in the early 20th century, you get a group of philosophers called the Vienna School who started something called logical positivism. And they basically threw out all causal talk and tried to get a very precise scientific language that we could use to express our theories in. that didn't have any unobservable stuff and that could be completely logically analysed in a sort of perfectly crystal clear order. So they said explicitly that scientific practice is not about causes, it's about manipulating and measuring variables. So we should only be interested in variables, and we should only ever talk about variables, we should never talk about causes. So we should replace all of our causal talk with talk about variables. And this became implemented in something called functional analysis in psychology. And this is sort of Skinner's term. He was the sort of behaviourist psychologist that really brought all of this stuff into psychology, from where all of your fields have inherited this framework. So we have a measured variable, which is your dependent variable. So that's your effect, that's your outcome. That's the thing that you're measuring. You have your manipulated variable, that's your independent variable. And the role of science is to explain, predict, and control these dependent variables, these things that you can measure, in terms of these independent variables, these things that you can manipulate. So this is problematic for your fields. This is problematic generally because this sort of the expectation here is that what you're doing is experimentation. And I don't think experimentation was relevant for anybody from what you said. Maybe for Leah, I think that's about it. Because you don't actually have any specific interventions that you're running. But this was the way of sort of framing how we should do statistics and how we should look at the world. I'll skip through the example. But happiness provides a good example, right? So we can't measure making people happy. We can't measure what causes happiness. We can only measure certain outcomes that we interpret as being happy. So I'll go through the example. So imagine if we wanted to compare two different countries in gender equality on the workplace. We could have a dependent variable. And that dependent variable might be, say, yearly income between two different genders. Is there a gender wage gap in a country? And we would have some independent variables that we're treating as though they're experimentally manipulated, as though there's been some sort of intervention conducted. Men versus women in, say, Denmark versus Australia. So our question is there a gender wage gap between men and women in Australia, in Denmark? But we're not going out and manipulating these things. This is natural occurring variables. And a possible finding might be that there's greater gender equality in one of the two labour markets. Okay, so that brings us to doing quantitative research on things that aren't quantities. So this brings us to this how do we measure something that's not tangible? How do we measure something that's conceptual and that doesn't map directly onto numbers? Well, we've already used this trick here. So gender equality is not measurable. Gender equality is a social construction. Gender equality doesn't have numbers associated with it. So we can't measure it directly. We have to put in something that is measurable and say that that means gender equality. So analytically, we sort of, by fiat, force that to now mean gender equality. And when we do this, we call this sort of making an operational definition. So here we're saying, and this is a good way to make your assumptions explicit if you're doing this sort of research, we operationally define gender equality as income, as wage gaps. So you can't quantify equality directly. It can't be a dependent variable. You can quantify yearly income, and that can stand in for your dependent variable. So this is sort of this definition by fiat we call operational definitions, so that your measure operates as that concept. So this sort of gives us two methodological criteria that we're using when we're applying this model, when we're doing sort of quantitative numerical analysis and applying this sort of statistical framework. And one is this operationalism and one is generality. So the basic idea is here, if we operationally define a concept that can't be quantified in terms of a variable that can, so we're taking a variable, putting it in for a concept, and our operational definition sufficiently captures the relevant aspect of the concept we're trying to measure, then what we're trying to learn about the variable can be inferred to also hold for the concept. And it's very important when you're sort of doing peer review that this is always debatable. So keep this open. So this is always debatable in your research teams, this is always debatable in your own research. Have you got the right operational definition for the concept that you want to capture? So here we could have a discussion about whether or not lack of fear is a good measure of happiness, and whether all the things we say about happiness actually hold, given that what we really know about is lack of fear. And that's never a closed discussion, so always keep that open. Generality, because essentially what we want to always do is make sure that we can discuss the semantics of our operation, of our functional analysis. That the functional analysis doesn't close off possible interpretations. So generality is, the idea is if we do this properly, then what we learn about one sample of behaviours from a sample of people can be universalised to express something more general about where those samples were taken from. So that we can make inferences at a sort of a population level. And to do this, you need to define your sample, you need to define your population, you need to define the relationship between them. And again, this is not a mathematical thing. This has to be done conceptually and this has to be debated. And it's only if you stick to both of these that your inferences will be meaningful. Yep?
Yeah, I'm just wondering, since we're in humanities setting,
what
about culture? I mean, there are so many different cultures, and fear in one culture may not be relevant in another.
Exactly, and that's one of the parameters that you're going to debate in this conversation, I think.
Yeah.
I mean, there's a pragmatics, we're all researchers here, there's a pragmatics of research as well. You've got to get your stuff published. So you'll measure a sample in Denmark and say that this is how it is for everybody. But I think presenting your work verbally, try to get it into your papers, try to put it in after the peer review is finished, is raising these red flags is important. And I think Denmark's a really good case. So a lot of epidemiologists say we don't need statistics in Denmark because we've got the population. Because all statistics does is it relates a sample to a population. But as soon as there's a child born, you don't have the population anymore. So time's another relevant factor as well. So there's all sorts of things can come into play here. But culture and time are two that are going to be very relevant for what you're doing. So basically what you're doing when you're doing statistics, when you're approaching a data set, when you're starting to approach a research question, when you're starting to set things up in the beginning, is you're following this process. You're starting with a concept. From that concept, you're deriving, if you're a hardcore logical empiricist, you derive this deductively, and then that deduction would hold and everything would be fine, but we don't live in that sort of world. You're defining an operational definition by fiat of that concept that you want to understand, which will give you a dependent variable that you then go out and measure in a sample, which will then allow you to make inferences to population in the real world, and which will then allow you to make inferences to the population at relevant times. So that's the process, basically. You're saying you've got this very diffuse concept like gender inequality that you then operationally defined in terms of the gender wage gap, which is a number, so we can do stats on it. You measure a sample, you go out and look at the wages of different men and different women in a society. You then make inferences to the population, and you can go wrong here too because you might measure the wrong people. For the inferences that you want to make, it's always relevant to the relative to the inferences that you want to make, not to objective truth. And then to the population at relevant times. Well, you might have not measured, there might be some change underway at the moment, there might be some dynamics in the labour market, so that what you've measured in 5 years ago when you started this project no longer holds or doesn't hold in the next 5 years. And it's important to be mindful of all of these things in this process. But basically what we're doing then is we're linking theory to data. That's all we're doing. And we're being mindful of what can go wrong along the way. So you're starting out with your theory at the conceptual level. You have reality, whatever that means, sort of beyond the data level. This is not your data. Your data's in the middle, actually. So your data is not the objective truth. There's a truth, we can assume that there's a truth out there, and your data is a reflection of that. And so what we're trying to do then is to link up theory and reality via your sample data. And that's essentially the goal here. And this is the process that you go through to do that. And certain things can go wrong at each of these stages. And the assumed philosophy of science that we're taking when we do this, so this is the ultimate foundation that we are assuming. So if you have problems with this, you need to learn a different kind of statistics. But again, this is the right place to start, is this logical empiricism that we inherited from Hume and reformulated through Carnap, and that Skinner then translated in a way that was friendly for psychology, and that then every other field adopted. And that's that knowledge of reality is based on concepts that are built up and mediated by empirical data. So basically, we get data, we have to build conceptual framework to understand that data, and that is the best we can do in terms of talking about reality. So, are there any questions about that sort of philosophical background? This is the sort of thing that you've heard before, and it's all just been stringed together and put in a context that could be useful for numbers. Okay, so from here, we'll start doing a walkthrough of R and RStudio. We might have a 15-minute break before we do that.
Here's the time if you don't have R or RStudio installed or are having difficulties, just put a tag up and I can sit down with you.
Green means you're okay, remember?
Yeah.